Chapter 12, Inference on Regression. This is section 12.1. So you have this least squares regression line that comes from looking at the association between two quantitative variables. So this is what we call bivariate, two variables, two quantitative variables. So assumptions, conditions, liner, we went through that. Just to speak about these, linear, you're checking is the scatter plot. Linear is the residual plot have no pattern. Independence is the 10% condition. Normal is whatever graph they gave you of the residuals have no strong skewness or outliers. Equal standard deviation. Does the residual plot have pretty consistent residuals? No cone shape. And random. Standard error about the line. That's just if you repeat the sampling process or the random assignment many times, that's the typical deviation from the sample slope to the true slope. Formula, you won't need to worry about that. Confidence interval, formula sheet, there's your statistic, plus or minus your standard error. You're not going to have to use any of these formulas. It'd be highly unlikely. So it's just plus or minus your critical value times your standard error, which you'll get from a computer output table. Test, statistic minus parameter, whatever your null value was, divided by that standard error. The degrees of freedom, different, n minus 2. So it's your sample size minus 2. So if we have this question here, find the least squares regression line. So I plug in GPA, assuming that's my explanatory variable, ACT score being my response variable. If I plug those into list 1 and list 2, and I do a linear regression on those, you'll have to be given, well, I'll come back to that in a minute. So you have the predicted ACT score equals the y-intercept plus the slope times the GPA. So if we're doing the confidence interval for the slope, I didn't go through all these 4 steps because we just did this fairly recently. You can look back at section 12.1. You take your slope, 7.69, your sample slope, plus or minus your critical value, 0.025 and 9 degrees of freedom, sample size minus 2. And then the standard error, they'd have to give you that. Otherwise, it would take forever. You'd have to do some serious calculations using the formulas on your formula sheet. Unlikely, but I guess possible. So you get your confidence interval. Are the results statistically significant? So basically, is 0 included in the confidence interval? It's not. So it looks like there's strong evidence of a positive linear relationship between the two because 0 is not included and the whole interval is positive. So moving on to this last page, we're running through the test. You defined beta, the true slope of the population least squares regression line relating GPA to ACT score. The null would be that there is no slope, it's 0. And the alternative would be that there's a positive slope. We're going to use our level of significance of 5%. Test statistic, similar to what we just saw, you're going to take that value, your sample slope minus your null, 0, divided by the standard error, you get 6.7. Your p-value is really small. You can write it in scientific notation when you do TCDF from 6.7 to infinity with 9 degrees of freedom, or essentially 0. So we'd end up rejecting the null. There's convincing evidence of a positive relationship. Last thing I want to do, looking at this computer output, make sure you understand what's going on here. The intercept, they typically refer to this as the constant, and this is going to be your explanatory variable, whatever the words that they put in the chart are. That'll be your y-intercept, your slope, and the standard error of your slope. Those are the 3 numbers that we're going to utilize. If we do a test, you could see your test statistic and your p-value. Remember, that's a 2-tailed test statistic. Or p-value, I mean. Things we talked about much earlier in the year. S is the standard deviation of the residuals, just on average what the distance is between the actual and the predicted values, whatever that is in context. And R squared, that's what percent of the variability that's explained by the linear model. So those are things you could be asked to interpret, any one of these 5 that's in this shape here. All right, that's it for review videos. Hopefully you found this last one helpful.